Hello everybody. In this video I'm going to work on the 3-digit problems that I gave out yesterday. So here's the first one, the sum of the digits in a 2-digit number. New number obtained when the digits are reversed. Okay, so I need the full setup of declarations here. So first we're going to go with t equals the tens digit, u equals the units digit. Then we need 10t plus u for the original number. And finally, we need 10u plus t for the number with reversed digits. All right. And then moving on to our equations, the sum of the digits is 10. All right, so equation 1, I'm going to write that over here. T plus u equals 10. And then equation 2 is the new number obtained when the digits are reversed. So I need the new number with the reversed digits. So that's 10u plus t. Is 18 more than the original? So I'm going to start with the original and then get 18 more than that. Okay, so there's my two equations. For my second equation, I'm going to clean that up a little bit. I'm going to subtract t from both sides. And I'm going to subtract u from both sides. And that leaves me with 9u. Oops, I wanted that to be in black. All right, 9u equals 9t plus 18. Let's see. I got a couple moves I can make here. I can divide everything by 9. Let's do that. Let's divide everything by 9. That looks nice and easy. And that leaves me with u equals t plus 2. So then that's from equation 2. Then I can substitute that into equation 1. So in equation 1, I'm going to say t plus, but instead of writing u, I'm going to write t plus 2 equals 10. So now I know that 2t plus 2 equals 10. And 2t, if I subtract 2 from both sides, would be 8. And therefore t, let's see, that's getting to the other thing there. So then t, I'm going to move over to this side. So then t equals 4 if I divide both sides by 2. And then by plugging back into this original equation 1, if t is 4, u has to be 6. So I believe the number is 46, because this is the tens. And we can test it. The sum of the two digits is 10. And then the reversed number, which I'll put in red, would be 64. So when the digits are reversed, it's 18 more than the original. And yes, it is. So this is the correct answer right here. All right, moving down. Let's go with that second. Whoa, not that far. Let's go with that second problem. There we go. Oh, geez. All right. So again, we are reversing digits. So we're going to need all the same declarations. So I'm going to, you should be rewriting these. So you practice them. I've obviously practiced them a whole lot. So I'm just going to move them down. All right, there we go. So we're going to need the exact same declarations. Oop. I'll get this figured out. Okay, and then over on the right, I'll make my equations. So let's put them in green. So it says the sum of the digits is 7. So we're going to say t plus u equals 7. We'll call this equation 1. In equation 2, the new number obtained when the digits are reversed. So we're going to reverse the digits again. 10u plus t is 27 less than the original. So we have the original, and then we need 27 less than that. So it looks like that. And similar to the last one, let's do that. Similar to the last one, I'm going to clean this up a little bit by subtracting t, and then I'm going to subtract u again. That seems to work out kind of nicely for several of these. So we end up with 9u equals 9t minus 27. I'm just going to do it the same way. I'm going to divide by 9 just because I notice everything's divisible by 9. If it wasn't, I would find some other way of doing this. There's so many ways that would work. So if you have another plan in mind, then go ahead and follow through with that. Okay, so that was all equation 2. So then I'm going to go back to equation 1 and do a little substitution here. So I'm going to write t plus u, like from up here, except instead of writing u, I'm going to write this stuff here. So I'm going to put t minus 3, 7. That's all from equation 1. So that means we have 2t minus 3 equals 7. I'm going to add 3 to both sides, so I get 2t equals 10. Divide both sides by 2. T equals 5. Now, plugging back into the original, if t equals 5, then u must equal 2, which would lead us to the original number being 52, and the reverse number being 25. Let's test it. 2 digits add up to 7, that's correct. And then the new number obtained is 27 less. 25, yep, so that works. So our answer is 52. Feeling good about that. All right, let's, I'll assume I'm using the same declarations here. So let's find out. Let's clone that. Move it down. Oh, what happened? They didn't move. Let's try that again. Oh, doesn't want to move. Oh, I just got some of it. Okay. Let's go back. All right. Moving back up. All right, we got. Oh, that's why. There's too much stuff in there. Okay. That's fine. We'll just go down. Okay, 2-digit number again is 7 times the sum of its digits. Okay, so this is going to use the exact same declarations, but the equations are going to look a little different, but it's still a direct translation. So equation 1, a 2-digit number, and we already know the number from the previous declarations is 10t plus u. The two-digit, I can't say that word, is 7 times the sum of its digits. So its digits are those, and we're summing them, and we multiply by 7. So there's one equation. And then the tens digit is, so the tens digit is 3 more, so 3 more than the units digit. Okay, so once again, this is set up really nicely for a substitution because this t is already isolated. And so we can, if we want, clean up the top equation first before substituting. You don't have to, but I'm going to. 7t plus u. By clean it up, I mean combining all these like terms. Whoops, I messed up. That's 7t plus 7u. There we go. All right, and then I'm going to subtract u from both sides. And I'm going to subtract 7t from both sides. So I'm basically combining the t's and u's here. So the result here is 3t equals 6u. And I can even divide by 3 if I want to clean it up even further. And so I will. And then we got t equals 2u. So now we have, in equation 1, we get t equals 2u. In equation 2 up here, we have t equals u plus 3. So I can substitute, and that's what I'm going to do. So I'm going to take from equation 1 this 2u is going to equal u plus 3, right? Because t, so these two t's, I'm basically just going to replace this t with 2u. Now I subtract u from both sides, leaving us with u equals 3. And then I can plug that in here. If u is 3, t is 6, meaning the number is 63. Now I'm going to test it. A 2-digit number is 7 times the sum of its digits. So 9 times 7 is 63, so that works. The tens digit is 3 more. Yeah, certainly. Okay, so there's the answer. No problem. I'll make another video on the other types of problems.